Assalamu alaikum. My name is Engineer Ghulam Murtaza. Today I am going to deliver a lecture on wind energy. Wind is created by the unequal heating of the Earth's surface by the sun. As a renewable resource, wind is classified according to the wind power classes, which are based on typical wind speeds. Actually, sun does not heat all parts of Earth equally. For example, land heats up faster than water. Therefore, different regions on Earth have different temperatures. The density of air at hot region is low, due to which it is uplifted. The air from nearby regions moves toward to the hot region to fill the evacuated region. In this way, movement of air occurs. As air moves, its velocity is used to produce electricity. Wind turbines convert the kinetic energy in, in wind into mechanical power that runs a generator to produce clean electricity. Basically, the kinetic energy of the wind is converted in mechanical energy, and then mechanical energy is converted to the electrical energy. And in this way, there is no any emissions of harmful gases. Therefore, we can say that clean electricity is produced. There are several reasons why wind energy is growing so rapidly. One of them is low cost, and second is that construction of wind energy takes months instead of years. It means the construction of wind energy plant is quick as compared to other electricity plants. Wind turbines do not produce atmospheric emission that causes acid rain or greenhouse gases. So we can also say that clean electricity is produced in this way, as there is no any emissions, no any harmful gases are produced. In other words, wind energy is both environmentally and economically sustainable. History of wind power. Wind power is being used from the ancient times. Wind power evolved from the use of simple light devices driven by aerodynamic forces to heavier drag devices. The sailboat is the earliest known use of wind power. Sailboat as well as ships were driven by the wind power from the ancient time. The first windmills were made to automate the tasks of grain grinding and water pumping in Persia, uh, 500 to 900 AD. It means uh, grinding of grain grinding and water pumping were also used from the ancient times. Wind as electricity. The first use of a windmill to generate electricity was in Cleveland, Ohio in 1888 by Charles F. Brush. The first windmill which was made to produce electricity in 1888. After that, further developments were made in 1891 and 1920 to improve its efficiency, to improve the design of its blades. Uh, but electricity production from the wind power started in 1888. There are different sizes and applications of wind power turbines. Small wind turbines uh, can produce about 10 kilowatt electricity, which is enough for home, for farms, or remote applications. And the intermediate windmills can produce 10 to 250 kilowatt. and it can be used to power a village or hybrid systems or distributed power. And large scale windmills can produce 660 kilowatt to 2 plus megawatt. As we increase the wind powers, the windmills, more wind power will be generated, which is used in central station wind farms, distributed power, community winds. Wind power is a measure of the energy available in the wind. It is a function of the cube third power of the wind speed. It means the production of electricity from wind mainly depends upon the wind speed. If the wind speed is doubled, power is the in the wind increases by a factor of 6. This relationship means that small differences in wind speed lead to large differences in power. Because of the wind speed or wind velocity has power cube, therefore it has a major role in the power generation. It is the equation of wind power. W is equal to half R A V cube. W is power and which is produced, and R is the density of the air. As at different regions the air density is different, therefore its factor is included in this equation. And A is the area of the rotor, and V is the wind speed or wind velocity. And we can see that V has cube, and it means the wind power is mainly dependent upon the wind speed. Because of this cube or this third power, other factors also play role, but the role of velocity is high as compared to other parameters. This equation shows that states that the power is equal to 1/2 times the air density times the rotor area times the cube of the wind speed. Air density varies according to the elevation, temperature, and weather fronts. Types of windmills, basically there are two types: vertical axis and horizontal axis. Although vertical axis wind turbines have existed for centuries, they are not as common as their horizontal counterparts. These are less common as compared to horizontal windmills. The main reason for this is that they do not take advantage of the higher wind speeds at higher elevations above the ground, as well as horizontal axis turbines. Uh, these are less advantage in case of wind speed. Because due to their rotation, if this mill is rotating anti-clockwise and wind is moving from right to left, then wind speed will favor movement of this blade, but it will not favor this portion of the mill or windmill or this blade, because its direction is opposite to the wind. Its direction is along the wind direction, but its direction is opposite to the wind. Due to this reason, these are less common, and these mills uh, does not these mills do not take much advantage of the air velocity. Horizontal axis turbine. This is the most common wind turbine design. In addition to being parallel to the ground, the axis of the blade rotation is parallel to the wind flow. And this is the blade of the windmill, and this is the axis. The air flow is same as the axis of the windmill, or we can say that airflow is parallel to the axis of the windmill. Some machines are designed to operate in an upwind mode with the blades upwind of the tower. If air is flowing from left to right, uh, in this way, the air will strike on blades first, then it will move to the tower. Therefore, we can say that it is upwind. In this case, a tail vane is usually used to keep the blades facing into the wind, and it is a vane blade. The purpose of this vane blade is to keep the uh, face of the blades in the direction of the air, so that maximum air velocity uh, can be converted into electricity. This vane will this vane will face the blades toward the air direction. In this way, maximum energy can be converted into electricity. Other designs operate in downwind mode so that the wind passes the tower before striking the blades. In opposite to this design, if air is coming from this, then air will strike with the tower first, then with the blades. Then it will be, we can say that it will be uh, uh, other design operate in a downwind. We can say that it is downwind. If air is coming from this side, then we can say that it is upwind. Otherwise, we can say if air is coming from this side, we can say it downside, downwind. In downwind, air will strike with the tower first, then with the blades. These are the parts of the wind turbine. We can say that it is a water blade, and it is the tower, and it is the hub. And in second diagram, we can say that it is the rotor hub. After there is a brake. Brake is also used in the windmill. Sometimes air velocity is so high, and it can damage the blades. So to avoid this damage or accident, brakes are applied so that it will be stopped, and no any destruction or no any accident will occur. It is a shaft, specifically low speed shaft. This is connected to the rotor. Rotor speed is not very high, therefore it is a low speed shaft. And it is a gearbox. It will increase the speed of shaft. It is gearbox is connected between the low speed shaft and the high speed shaft. After that, the RPM will be increased, and this high speed shaft is connected with the generator, and then electricity will be produced. These are the major parts. Similarly, that is further explained. Uh, these are the blades, and it is a low speed shaft, and it is a brake. Sometimes it can be used if air velocity is increased, and it is a gearbox, and it is a generator, and it is a controller. Controller is also installed. It is an anemometer which will sense the air velocity and give signal to the controller, and eventually the controller will control the whole process when it is needed to apply the brakes or not. If the speed is high, then controller will send signal to the brakes, and the shaft will be stopped to avoid any accident. Main parts of the windmills are rotor, The hub and the blades together are referred to as the rotor. Wind turns the blades, which turn the drive shaft. Shaft, two different shafts turn the generator. One is used for the low speed, while the another is used in high speed. Gearbox, gears connect the high and low speed shafts and increase the horizontal rotational speeds from about 10 to 60 rotations per minute to about 1200 to 1800 rpm. This RPM can be increased with the help of gearbox. Actually, the generator requires high RPM to produce electricity. The rotational speed required by the most generator to produce power. In this way, electricity is produced. Generator, the generator is what converts the turning motion of a wind turbine's blades into electricity. Inside this component, coils of wire are rotated in a magnetic field to produce electricity. When the coils are rotated in a magnetic field, then electricity is produced. And the rotation is done by the shafts, as we discussed earlier. Different generators design produce either alternating current or direct current, and they are available in a large range of output power ratings. Both currents, alternating or direct current, can be produced in this way. The generator's rating or size is dependent on the length of the wind turbine's blades because more energy is captured by longer blades. Controller turns the blade on at 8 to 16 miles per hour and shuts them down around 65 to prevent any high wind damage. This is the suitable range of the wind velocity. 8 to 16 miles per hour wind speed is most suitable for electricity generation from the windmills. If it increases, as we can see that it is 65, then controller will uh, stop the wind turbine by applying the brakes to avoid any damage, any accident. Tower, tall tubular metal shaft, the taller the tower, the more power produced. As we increase the height, more air will be flow, the air velocity will be high. In this way, the more electricity will be produced. Pros of the wind power. Wind power units are quickly constructed. Like other electricity resources, it has less time to construct. Wind generators are much smaller in size compared to other types of electrical generators. Small size allows wind power to be very versatile. If we have more land, we can install more windmills. If we have less land, we can construct uh, less windmills. We have it is dependent upon the availability of the resources, availability of the land. Wind power is a great complement to a house with a pre-existing photovoltaic system. Photovoltaic system works in daytime. When sunlight is available, it will work. But in case of wind turbine, it will work 24 hours. Serves as a great backup system. Wind power gives off no harmful emissions into the environment. No any harmful gases are emitted, no any harmful gases are produced in this way, and no any emissions are existing. Therefore, it is a clean electricity production, and it has no any effect on environment. It is a renewable resource. The more time spent Researching makes each new wind turbine more efficient. Research is being done to increase its efficiency. Mass production of wind turbines drives down costs. The wind blows day and night, which allows windmills to produce electricity throughout the day. 24 hours we can generate electricity, but faster during the day. As the temperature difference increases during the daytime, therefore more velocity exists in daytime and more energy can be produced. Energy output from a wind turbine will vary as the wind varies, although the most rapid variations will to some extent be compensated for by the inertia of the wind turbine rotor. Wind energy is a domestic renewable source of energy that generates low pollution and has little environmental impact. Up to 95% of land used for wind farms can also be used for other profitable activities, including ranching, farming, and forestry. This is a great benefit of wind power that along the wind power generation, we can also use that land for the farming or forestry purposes. As very small land or very small space is required for a windmill. The remaining land can be used for farming or other purposes. The decreasing cost of wind power and the growing interest in renewable energy sources should ensure that wind power will become a viable energy source in the United States and worldwide. Wind energy in Pakistan. Pakistan has 1,046 kilometer coastline in the south. Average wind speed more than 7 meter per second in Garu wind corridor. 7 meter per second is sufficient velocity of the air to produce electricity. If more than 7 meter per second velocity exists, then it is feasible for production of electricity from wind power. Estimated wind potential more than 50,000 megawatt. It is a great for us if we recover, uh, if we produce electricity from wind powers turbines, and it can decrease the load shedding or mitigate the load shedding. Other sites in Balochistan, Punjab, and northern areas being identified. It is a map of Pakistan, and this is a Garu wind corridor, uh, which is most suitable area to produce electricity from wind turbine. And these are the sites in Balochistan which are feasible to produce electricity from windmill. And these are the locations in Sindh which are suitable for wind power generation.